We know from our previous video, we know that the derivative with respect to x of the inverse sine of x was equal to 1 over the square root of 1 minus x squared. That's the derivative of inverse sine. We could go through the same process really to find the remainders, but we're going to go ahead and just address what they are. The remaining inverse trig functions, or at least the derivatives of the inverse trig functions, can be derived in a similar fashion. But here they are. We're going to kind of redo this just a little bit and say the derivative of the inverse sine of u, where u is a function of x, because I really need to, now that we know the chain rule, we really need to incorporate it into our differentiation rules as we learn them. So in this case, u is going to be a function of x. Well, what it is it's 1 over, and I'm going to put the numerator here in a second, the square root of 1 minus u squared. Now then, times the derivative of u. That's what the chain rule would tell me to do. I need to multiply this by the derivative of u, where u is some function of x, and so u prime is going to be in the numerator. So for all of these inverse trig derivatives you're about to see, understand that they're going to have u prime, and that's going to be because the chain rule is acting in concert with these other derivatives. So there's the derivative of inverse sine of a function. Let's take a look at the derivative. Well, let's go kind of down. Let's go down this way here first. The derivative of inverse cosine of u. Just like the derivative of sine and cosine differ by negatives, that's also going to be true here. This is negative u prime over the square root of 1 minus u squared. And the derivative with respect to x of the tangent of x, inverse tangent of x rather, I should say, ends up equaling u prime. Again, that's from the chain rule over 1 plus u squared. All right, let's take a look kind of going across inverse sine, 1 over sine, that's cosecant. So let's take a look at the derivative of inverse cosecant of u. That is negative u prime. Again, that's coming from the chain rule. The denominator is the absolute value of u times the square root of u squared minus 1. Now then, if I take a look at the derivative with respect to x of inverse secant of u, that is u prime over the absolute value of u times the square root of u squared minus 1. And then the last one that we have to address, the derivative with respect to x of inverse cotangent of u, is negative u prime over 1 plus u squared. So obviously some derivatives a little bit more complicated than our 6 trig derivatives were from Unit 2. There are some nice patterns that emerge. For example, the co-functions, cosine, cosecant, cotangents. For the inverse functions, their derivatives also come out negative. You'll see that sine and cosine, inverse sine and inverse cosine, have similar looking derivatives, differing just by a negative. Same is also true for inverse tangent and inverse cotangent, and inverse secant and inverse cosecant. So there are some familiar patterns there to the derivatives of the inverse trig functions that also existed when we took the derivatives of the trig functions in Unit 2. And just as a reminder, the u prime in each of these, that comes from the application of the chain rule. And in fact, we'll look at some examples in the next video, but be thinking about things like the inverse sine of 2x squared, for example. I would need to make sure I took the chain rule to get the derivative of that 2x squared. That's what this u prime in each of these inverse derivatives is telling us to do. And we'll take a look at how to actually take the derivatives of some of these inverse trig functions in the next video.